batter, wearing the typical baseball, and then he hits ball like so. All right, and so we're just going to, for our own convenience, define y equals to 0 to be this, right?
Yes.
All right, so my first move here, in this kind of question, this is not a very sneaky question. This is kind of just like an in-your-face, step-by-step sort of put it together, use the equations, work it out. It's got a lot of parts, but it's actually pretty simple. So I guess my first move is to figure out the x and y components of the initial velocity. So let's see here. So I got v naught, my initial speed, right? And the angle theta is what? It's 36.9 degrees. So let's see here. V naught x is v naught cosine of 36 cosine theta. So that's, what was my v naught? My initial speed was 30 meters per second. So I would have 30 meters per second times the cosine of 36.9 degrees. Can you guys tell me what that number is? What is it? 20 what?
3.99.
23.99. Okay, I'll take it. So there's your initial x velocity. What's the initial y velocity?
18.013.
So that's 30 meters per second times the sine of 36.9. And you just told me, I forgot already.
18.013.
18.013. I'll take 18.01 meters per second. So there you go. There's your x. Your initial x and y velocities. Once I have those, it's easy enough to write down the equations of motion for x and y. So for x of t is what? X of t is x naught, the initial time. So let's say that the ball is hit at x equals to 0, right? And let's also assume that that's t equals to 0 as well, okay? I mean, why not? So let's see here. So this is 18. Ooh, yeah. Sorry. 23.99 times time. So it's just the speed times the time that gives you the distance, because there's what? Constant velocity in the x direction. There's no x acceleration. Okay, y, in contrast, would be what? Y would be, y at time t would be equal to, well, let's see here, 18.01. T, that's my motion, which comes from the initial velocity that it has. And then I do minus 4.9 t squared. Right? So these are the so-called equations of motion. If you wonder, if I tell you to find the equations of motion, I'm just saying find x of t and y of t. All right? Because those equations describe the motion. So that's why they're called the equations of motion. I'm telling you this because at times people are confused about what I mean when I say find the equations of motion. So then what? At what two times is the baseball at a height of 10 meters per second? 10 meters per second, look at me. A height of 10 meters above the point at which it's hit, right? So if I was to draw that, it's something like maybe here, right? 10 meters up. And as you can see, theoretically, there's going to be two times, t1 and t2, at which we get y equals to 0. So how do you find those times? You set 10 equal to 18.01 times time minus 4.9 t squared. And you have to solve this quadratic equation, right? Let's not look at my email. www.wolfram.com. Hard to beat it. 10 equals 18.01. Sorry, I don't trust you guys. It's just that I don't trust you guys. times t. I mean, I trust you. But as Ronald Reagan once said, very good. Gentlemen in the audience said trust but verify for the home viewers. I don't know who I'm talking to. There's really nobody watching this, you guys. Right? I mean, even you is quite debatable. Let's see here. What? Okay, I like that. Although you should understand that this is not, it's funny, right? You think, oh, that's just like that, right? These are not the same graph at all. They happen to have the same shape. But you should notice, this is x, this is y. Here you're looking at y versus t. It just happens to be that they're both parabolas. Anyway, what did we get? Come on. Wolfram alpha?
There.
Paid good money for this solution. See here, T1 equals to, that's a different, 0.68.
That's better.
Oh, 1.7 seconds, of course. T2 equals 2.994 seconds. Make lazy and just keeping coordinates. All right, get out of this thing. Go back to our happy place. Maybe that's a misstatement. All right. So, 0.682, 2.99. So there's the answer to the first two boxes, right there. Then what are we supposed to answer? Calculate the horizontal and vertical components of the baseball's velocity at each of the two times calculated in part A. Okay, so I haven't even written those formulas down yet, have I? So these are the equations of motion, right? These are the formulas for position, right? The components of position vector, right? So like position r would be x comma y here, right? But the velocity in the x direction at time t is very boring, right? It's equal to what? It's v naught x, right? It's constant velocity, right? In the x direction, there's no acceleration that way. So it's, yeah, you said it's 23.99 meters per second. And that's true at any time. It's constant. Dy, on the other hand, is a little bit more exciting. Dy of t is v naught y minus gt. All right? Because the acceleration is constant. And so that's what? That's 18.01 meters per second minus 9.8 meters per second squared times time. So how do I find the y velocities? So like dy of t1 is what? Dy of t2 is what? We just have to plug in those times. 18.01 minus 9.8 times 0.681, right? And 18.01 minus 9.8 times 2.994. What do we get? I mean, I'm going to be lazy and tell you what we get. We get, for time 1, 11.3 meters per second. And for time 2, we get minus 11.3 meters per second. So I'll put that in orange. Does it make sense that it's like the same magnitude but opposite sign?
Yes.
Right, there's that symmetry in the motion. What goes up must come down, all things being equal in the same way, right? Ignoring friction. If there actually was friction, the ascent and the descent would be different. Right? You have more friction on the way up and less on the way down because the speed would be higher on the way up. And generally speaking, friction depends on the velocity. More velocity, more friction. Less velocity, less friction.
So does that mean like the magnitude of the y would be like more or less than the second one?
It would be less if there was friction, but we ignored that.
So it's equal.
Good news, we can use these happy polynomial equations to answer our question. We don't have to think about solving differential equations that we don't know how to solve yet. Okay. Oh, and then, so do you see that? And then finally, what are the magnitude and direction of the baseball's velocity when it returns to the level at which it left the bat?
It's the same.
It's the same. It's the speed, but the difference is this angle is below the horizon, right? So if I was to draw that, it would be like this. I mean, now you don't have to assume that. You can work it out, right? How would you work it out?
Change it. Inverse it.
You set this orange equation, and replace the 10 with a 0, right? That would give you the time at which it reaches this point. Then you would plug that time into the dy equation. That would tell you the y velocity at that time. The x velocity is the same. You would square those, add them together, take the square root. That would give you the speed, and you'd find out it was the same. Or you can just use common sense and see that it's the same. Although that common sense is really only justified with math. Yep.
How would you calculate when it hits the ground if you start at a point above the ground?
I would need to know the height of the baseball player. I would need to know what this distance was. So if it had, for example, if that was 2 meters, I mean, that's kind of a lot, but suppose that was 2 meters, then I would have to go back here to find the time at which it hit the ground. I would set this equal to -2. That would tell me, the larger time would tell me the time it got to like here, right? Once I found that time, I would plug it back into the x equation, and that would tell me how far over. If I use the range equation would give me this distance, because the initial and the final height are the same. That's going to be, what's that going to be, 2 v naught squared sine 2 theta over g? Or there's no 2, right? It's just v naught squared sine 2 theta over g. That would be the range. But other questions? Yeah.
How would you do the 2 times without using Wolfram alpha?
Oh,
Like you just use quadratic
sure.
equation?
I don't mind that question. That is a question about math. So I'm trying to solve 10 equals to 18.01t minus 4.9t squared. Okay, so how do I solve that? Well, first of all, I rearrange it so that it's my happy place, which is to say 4.9t squared minus 18.01t. Let's see here. Plus 10 equals to 0, right? So I look at this. This is a quadratic equation, and the coefficient of this, of the quadratic term, is a, right? A is equal to 4.9. This is b. B is equal to minus 18.01, and then that's my c, which is 10, right? Quadratic formula says that t is equal to minus t plus or minus the square root of b squared minus 4ac divided by 2a, right? And so you just plug those numbers in. So that's 18.01 plus or minus the square root of 18.01 squared minus 4 times 4.9 times 10. Hopefully this doesn't come out to something negative, otherwise we lose. It's okay though, this is like, well.
No, because 18 squared.
That's okay. Oh, and then 2 times 4.9, we know what that is, that's 9.8. I mean, 4.9 came from dividing 9.8 by 2, and now we're multiplying it by 2, which undoes the anyway. Or you could just notice that 2 times 4.9 is 9.8. But that's not so exciting. And then you just work that out, which is why I didn't do it in Spain. But, yeah, so like if I ask you for a time on the test and then you leave me this, I will take off points. I mean, it's nice, you'll get some partial credit, but I will take off points. I want you to finish. Like answers on a physics test should be decimal numbers with a box around them with units on them. Okay.
Put units on the end of that.
This is not the answer, it's my point. This is
Yeah, we'll play that into the other equation. Put it everywhere.
Oh, no, And down here, see? Exactly. Yes.
In that scenario, if the time we're looking for is really just the positive or the greater time, would you like us to only box that time, or should we box both times?
Depends on the question.
Okay. So the relevant one, just box that.
Yeah, I
Don't,
mean,
don't worry about the
Right,
irrelevant
if
answer.
the question is geared towards finding the time a particular thing happens and then through some physical intuition or common sense or whatever you might call it, you know that the positive solution is the one you're looking for, then yeah, you can just look for that one, right? But depending on the signs of things, positive solution may or may not be the later time. No, no.
The solution always works out probably.
Yeah.
On the test, would you want us to do out the quadratic formula by hand, or just make a note that we plugged it into a quadratic equation solver?
I will allow you to use the quadratic equation solver on your calculator if you got one, but you should say that you did that. Yeah.
Simple question.
I mean, I can't stop you, so it would be kind of like, you know, I put $100 on in front of everybody in the test. I say, don't take it.
Let's try that. And then
I don't have
we'll
it
find
in
out.
mind. I mean, maybe Chinese dollars. I don't know.
You don't care for worth the units on the test, right? Just don't
The work need not have units, in as much as it doesn't confuse having the right answer. If you have a problem which has centimeters and meters in it, and you ignore units, ignore them to your peril. If you see a kilometer and you ignore that it's 1,000 meters, it will hurt you, right? But the answer must have like seconds on it or meters per second. But I don't much care, like I did right here. I wrote this without meters per second, right? And you don't have to write units on intermediate stuff. I don't care about that too much. Yeah.
Do we need to know any like conversion between metric and English?
That would be a good thing to put on your card. I might ask a conversion question. I would usually provide enough in the question for you to make sense of it, right? But I'm not, it would be fine if you had on your card something like the conversion between meters per second and miles per hour. Some things like that might be helpful to you in order to check your answer. But if I was to say, find the number of basketball courts per minute that is the same as 50 miles per hour, I mean, you do need to show your work, right? I mean, if you happen to have how many basketball courts per minute it was the same as mile per hour in your card, like that's nice and all, you can copy it down, but I would want to see the work. So you can write down conversions on the 3x5 card you guys get, but beware if I ask a conversion question, you got to show your work, right? A more likely question, how many square inches are there in a square mile? For example, yeah.
Did I miss something about note cards?
You are allowed to have a 3x5 card.
Inches.
3x5 meters.
Oh, I forgot.
In this print.
He's
got every single homework question.
How does he get around that?
It happened. That's all I can tell you guys.
Yeah, you said we can't go.
I know it's in here somewhere. I've got, where is it? Like 2 pages. No.
There it is. Oh, there it is. Yeah, I know. I hid it in the syllabus, which is, you know, it's a pretty good place to hide stuff. I guess if I wanted to put my retirement somewhere, people wouldn't find it. There was a way to converting it to syllabi, it would be safe. Government has no syllabi tax, right? Really convert back and forth from syllabi to free money. When I retired in Nicaragua or whatever, I just I went syllabi, put them in a box. How many syllabi you need to buy a house? I don't know. I don't think this is really something I can do. I guess you would get candied pineapples instead. But then they only last.
Syllabi will you give us?
What's that?
How many syllabi will you give me if I figure out how to convert your mind to syllabi?
Yeah, so you get a 3x5 inch card for each test, okay? I don't give you one, it's up to you guys to make it, right? I think I let you bring, you should save them, you get to keep them, you can bring all of your 3x5 cards to the final, so that would mean you'd have like 3 of them, and then I'll let you make a 4th one for whatever we go past that 3, and then on the final you'll have these 4 3x5 cards with all of the glorious mechanics knowledge all in one big place. Now, one thing I haven't said anything about in a little bit, but it's definitely on the test, is vectors, right? And not just vectors as you saw them in WebAssign, vectors as I presented in the lecture, right? So maybe there's not a unit vector question on WebAssign, but that doesn't mean I don't care about unit vectors. I certainly care about unit vectors, right? So it's important that you study the lectures we had early on about how to find unit vectors, right? Standard angle, magnitude, breaking it into components, adding them, either analytically or geometrically like you learned in the lab, remember? In detail, right? I might ask a qualitative question, which is just based on, can you see how to add them without actually putting lengths or specific angles, right? You could just, have multiple choice and pick one. I said I wouldn't do multiple choice, but that's not quite accurate, because I might ask a multiple choice, which is like, here are 2 vectors. Which one of the following 4 things is the sum of the 2 vectors? Like that's about the extent of a multiple choice question or last second test. Just because I don't want to grade you guys writing, it's just easier to give you 4 possibilities and let you pick the right one, yeah? Yes, sir?
Do you have to worry about dot product and cross product for this test?
Absolutely. Yes, dot product and cross products are definitely fair game.
Are you gonna do that?
Yeah.
How long is basketball for?
I don't know. I would say that that question is out, but then again, I don't know how to use the tool. Actually, Wolfram Alpha is the right tool for that.
It is.
What was the question?
Sure. How many basketball courts?
It's not just.
How many basketball
Which someone already asked us.
courts in a mile?
94 feet by 50 feet.
That's right, it's 50 feet.
Don't let me down. You can do it. You can do it. Oh. Well. Well, you have 94 feet. Picture.
Five basketball courts. How many
I don't know.
Ask us how long.
I'm a computer.
Oh, like the singularity? When is the singularity?
Oh my god.
Well, that's not the answer I wanted. Oh, not understanding.
What is the loneliest number?
Ask it, who shot first?
Yes.
I'm not sure how much it's helped us with the test, but I like it.
The third question was asked, who shot first?
Harrison Ford.
Oh, related. We somehow get some Santa Claus. Who comes down the chimney on Christmas. Okay. Any other questions? Yeah.
You mentioned standard angle. Is that just the angle between the x-axis on the right positive side and the vector, or the angle between 2 vectors?
Standard angle is the standard angle. So the standard angle, what that means is the angle of a vector as measured from the positive x-axis in the counterclockwise fashion. So now I will agree that there is a slight ambiguity. So like here, we might have theta is 50 degrees, right? This would be theta 130 degrees-ish. Over here, you got something like 210 degrees, give or take. This guy, yeah, I don't know, 330 degrees, maybe, I don't know. These are obviously approximate. My point to you is that if you really understand these four cases, that's a good sign. But these are the four different quadrants, right? Now, if I told you that the length of this vector was, say, 10, right? Could you tell me then, without a lot of work, what the x and y coordinates are of each vector, how many components?
Yes.
So like here, it's always the case, in every single case, v is equal to the magnitude times the cosine of the standard angle, the magnitude times the sine of the standard angle. Another way to look at this is that it's v times cosine theta sine theta. By the way, to put a hat on this, this is v hat. That's the unit vector in the direction of the vector v. So there's a one-to-one correspondence between standard angle and the unit vector in which the vector points in 2 dimensions. You can freely go back and forth between these two viewpoints. However, if I ask for the standard angle, I do expect the standard angle, right? If I just ask for the direction of the vector, I leave myself open for ambiguity. I will either accept the unit vector which points in the direction of the vector, or I would accept the standard angle in 2-dimensional context. In 3 dimensions, if I ask for the direction of the vector, pretty much have to give me the unit vector, because in 3 dimensions we don't have a standard angle. We need 2. Anyway, so let's see, like this one would be what? You guys tell me explicitly? This would be v equals to, what is it? Cosine of 50 is what?
Remember.
6.43? And then what's the sine of 50? 7.66, okay. And let's see, over here, v is what? What's the cosine of 130? Minus 7 point, really?
It's just 7.
Okay, minus 7.66. Cosine of 130 should be negative.
I got minus 6 point.
Minus 6 point. Minus 0.63?
No, minus 6.43.
Oh, okay, but you're multiplying by 10 though, aren't you? I mean, I know you are, because cosine is between, magnitude is between, is from 0 to 1, right? And then the x is what? I guess it's 7.66, huh? All right, then here, that makes this angle here 30 degrees, so that means I can figure things out. For example, the sine of 30 degrees is a half, so this is going to be minus 8.66 and minus 5. I know that because I know that the sine of 30 is 0.5, and I know that the cosine of 30 is about 0.866, because that's the square root of 3 over 2. These are just things I happen to know. I also know that cosine and sine of 210 degrees is negative, which is consistent with the fact that standard angles of 180 to 270 fall in this quadrant where both the x and the y components are negative, right? And then this guy over here is what? If that's 330, that makes this angle what? 60. So let's see, I can use my figure, and cosine of 60 is the half, so that makes this 5 comma minus 8.66, I think. Roughly speaking, of course, but.
Wouldn't it be the other way around?
It would cosine.
Because cosine 60 would be like.
Just let me think for a second. You guys might be right.
Since essentially.
Yeah, you guys are right. Sorry. And that is the danger of using a non-standard angle. And then applying the, I mean, you have to be careful, right? Because the sine is the horizontal in this case, right? So, but the cosine is the adjacent side to that 60 degree, right? That's why minus 5 goes in here. Now, of course, you could have avoided all that by just taking the cosine of 330 and the sine of 330, and those would have given you the correct x and y components, right? I mean, nothing wrong with using 60 degrees, but you got to use it with understanding, right? which is the opposite side, which is the adjacent side, right? You can't get away from that. It always comes back to that. I mean, you can get away from it. It's to really embrace polar coordinates and things, but it's not a very good sacrifice to divorce yourself from geometry for the sake of some formulas you can always use. Right? Anyway, yes?
Do you have a problem with 3 dimensions with unit vectors?
Problem with 3 dimensions of unit vectors, I certainly can. Do it over here. So here's a standard question. Let V equal to, gee, I don't know, 3, 2, 7. And let's find the unit vector in the direction of V. Find V hat and find same direction as V, but length 10. All right. So first of all, how do you find the unit vector? What does that mean? This is generically true, okay, guys? V is equal to the magnitude of V times V hat. That's what the unit vector is. It's this vector which encapsulates the direction of the vector. So if I take the magnitude times the direction, that gives me the vector. I mean, this is actually a formula for that. Now, of course, I mean, the definition of V hat, if you like, is just this. I do 1 over the magnitude times the vector. So this is actually how to calculate V hat. So I have to calculate the length of the vector, which we just call V. So V, I use this notation sometimes, right? So it's the square root of 3 squared plus 2 squared plus 7 squared, which is 9 plus 4 is 13. 13 plus 49 is, what did you say, 62? So the square root of 62, which is about 7.8. 7.8? 7.9? What's it?
874.
Oh, 7.84?
7.8.
Oh, 7.74?
7.87. 7.87.
Tell me the whole number.
7.874.
Oh, 7.874. Okay. Sorry, eventually we'll get it. I kept trying to hear you guys saying some number larger than 8. I couldn't get my mind on that. Because, of course, the square root of 64 is 8, right? So I knew it had to be some number less than 8, but more than 7. Because 7, square root of 49 is 7, right? So, but anyway, you have calculators. So this, short of the robot holocaust or that singularity. And though we have to we should consider the singularity extending to handheld calculators now to get Wi-Fi. I mean, that's a real thing for like you guys with Inspire. You would put those away from yourself when singularity happens, they could get you somehow. I mean, I don't know how a TI Inspire could hurt you, like physically hurt you, but electrocute you. I guess it would tell the other machines where you were. And there's that. It could spy on you. We got the government for that. So, I mean, you got nothing to hide. What do you care about if you're spying on, right? It's way. So V hat 1 over 7 point. Somebody asked me a question a minute ago. I'm sorry, I need to get back to it. 327. So there you go. That's. I mean, I personally like that format for the unit vector. Of course, you can scalar multiply this inside and get actual, numbers. In an actual unit vector, if you actually have it written out as like A, comma B, comma C, A, B, and C should all have magnitude less than 1. Otherwise, the sum of their squares will be greater than 1. So as you can see, 3, 2, and 7 are all numbers that are smaller than 7.8. If I actually brought this fraction in here, we'd have, decimals less than 1. Okay, so then what's the answer to my other question? Length 10, how do you, yeah.
Do you prefer us to kill the radical and not
Oh,
work
yeah.
that way?
Oh, I don't, I mean, for this question, I wouldn't much care one way or the other.
Okay.
Generically speaking, I do like you to kill the radical, especially for an actual problem with like, it's got, if there's like a baseball player in it, or anything with degrees, generically speaking, I want a decimal.
Yeah.
For this, I don't much care because it's, maybe I should care just to be uniform in my caring, but I guess I don't care about that. So, yeah, that would also be an acceptable answer here. What's W?
10 times that.
Yeah, so W would just be 10 times V hat. So it'd be 10 over the square root of 62 times 327. Of course, there's other ways to write this answer, right? I mean, you can write it as blah, blah, blah. Whatever those happen to be. That would also be fun. You guys, make sure you know how to find the direction of the cross product.
Right hand rule.
Left hand rule, right?
Correct. The left-hand rule. The left-hand rule is if you want to find the direction of A cross B, you go point your left hand in the direction of B and you cross it in the direction of A, and that gives you the direction of the cross product.
Sure.
I mean, that gives you minus the direction of the cross product. Yes, let's use the right-hand rule. A crossed into B, the thumb points in the direction of A cross B. Right? So, I do think you had some web assign on that, so you have a sense of what are reasonable, so the multiple choice questions about it. The other thing I would remind you is there are two really important formulas about dot products and cross products. What are they?
Scalar vector.
Hey, go on.
Cosine theta.
Go. Oh, so before I get that out of my system, here's like a pretty popular test question, something like this, right? And I would have better wording, like on the test I would say find the magnitude and the standard angle for R. Do you guys see why 30% of the class gets this wrong?
Because C is weird.
Yeah. Did you see the track?
Yes.
Yeah, so this C, either, I mean, there's different ways to deal with this, but one way to deal with this is just to put C where it belongs, which is up here, right? And then and go from there, right? But anyway, in the actual test, I would have angles, right? I might have, who knows which angles I give you. I may not give you the standard angles for the vectors. I give you some angles. I might describe them, right? I might say that B is a vector of length 10 in the direction which is 30 degrees west of north. 30 degrees west of north, what would that mean? Standard angle 120 degrees, very good. But directly, what directly this means is 30 degrees west of north. Right? You're right. That would correspond to a standard angle of 120 degrees. Very good. You guys are right. Okay, before I forget, the two most important formulas about dot products and cross products, besides their definition, of course, is A dot B, right, equals to AB cosine theta, and A cross B, the magnitude of that is AB sine theta. Now, there are other important interpretations. This is equal to the what? The magnitude of this, rather, right? This is, by the way, equal to the area of what? Yeah, it's like this little parallelogram like this, right? This area. How about A dot B? What does that mean geometrically? I don't know. I've never teach that. That's kind of funny, but no one ever bothers to say A dot B means this geometrically. I don't know. It's
What if it was the secret to curing cancer?
secret to curing cancer. Then if we hadn't found it by now, it would be very sad. So much news is tragedy. Surely we understand A dot B equals AB cosine theta. More to the point though, do you understand it? If I said, I've got a vector, I don't know, 1, 2, 4, and I say find the angle beta between, say this vector is A, between A and the positive y-axis, can you do it? A is the vector 1, 2, 4. So what I'm asking for is what's this angle? So positive y-axis is over here, right? So here's your y-hat. I'm asking for this angle.
Can we just use y hat for our cross?
Oh,
A-
oh,
A
no cross
y hat.
products. No cross products.
Oh, I'm sorry. As our second vector. That applies.
Oh, use y-hat as the second vector, yes. That's the right idea. So, I mean, so what you're getting at is I should look at A dotted with y-hat, right? That would be equal to the length of A times the length of y-hat, which is easy, times the cosine of the angle I'm interested in. Right? What is y-hat though? 0, 1, 0, very good. So what's A dot y-hat?
2.
It's just 2. What's the length of A?
Square root of 1 squared is 2 something.
Yeah, exactly. 1 plus 4 plus 16, right? So therefore, beta is the inverse cosine of 2 divided by the square root of 21. I would like an angle here. Because I'm faced with the following problem. Some of you put it in the calculator, do it wrong, right? Some of you put it in the calculator, do it right. Yet others of you don't put it in the calculator at all. How should I then grade? Well, I feel like I should reward the people who can figure out what the inverse cosine of a fraction is with their calculator. That is actually part of this course, as silly as it is part of this course. So, I have no choice really but to take a little bit of credit off the person who leaves their answer like this. I really do want degrees for angles.
How about radians?
If you want to use radians, you got to write radians next to it. But that will draw attention to your test. I grade other parts more carefully. For degrees, I would be amused by grads. But you guys know grads. So some system of there's 400 grads, and 400 grads, like 100 grads is 90 degrees or something. Why? I don't know. Europeans, I guess. Oh, so somebody tell me it's bothering me. Can somebody tell me the number of degrees here? Yeah. 64.12 is enough. I mean, 4 degrees, 4 numbers, generally speaking, is a good number of numbers, digits. Now, I hope by now you appreciate that the direct geometric attempt on this problem is a fool's errand. You must attack angles using the dot product, otherwise you will not be able to do it. Another popular test question. I give you 3 points. What can I do with those 3 points? I could connect the dots, right? And then I could do questions like, what's this angle? What's that angle? What's this angle? Right? You could calculate that. Even if that was a triangle in 3 dimensions, in some kind of screwy way, you could easily calculate that by doing what? By finding vectors along the sides, right? And using this dot product idea to find the angles. Yeah. I could ask for the area. Yeah, that's a straight the area of the barrel. Oh yes, very good. It's like you could take if I had A and B, I could take the cross product of this was A, and if this was B, I could take the cross product of A and E, calculate the magnitude of it, divided by 2, and that's the area. Very good. Yes, sir. Can I have 3 points to your score? Just give you the 3 points. I I mean, I would probably, let's say this, I would probably give you the 3 points, and then I would allow you to earn 30 more from it. So whether or not you decide to earn those 30 points. I mean, that's your prerogative. As I mentioned at the start of all of this, I don't require you to pass the class. I mean, it's optional. Right? I'm not a monster. I won't force you to pass. Right? So, I'm just kidding. Everyone passes. It's physics. Everyone has an A. Woo! Right, Bailey?